Hello 108 students, Mr. McHugh here with you. Going to work on section 2.5 and we're going to deal with linear inequalities in one variable. Okay, so we're going to take on page 1 here on this video, and strongly recommend everybody look in your textbook or your ebook, look on page 91, and there is a big table of interval notations reviewing the 1, 2, 3, 4, 5 major types with subdivisions underneath them. It will help you to spend some time looking at those. At that table, it's very well organized. They've got names for them from open interval to closed interval, half open, disjoint interval. I call those wings. When you look at that one, infinite intervals where you start at one side and you go left or right, or you go the entire negative infinity to infinity. Okay, so what I'm going to do here in my class notes here, I picked a couple of these and I want to help everybody make a transition. I think I've talked about it before, but you got to get used to not using open circles and closed circles. So, and then you've got to use a parentheses, either left or right hand parentheses for when you do not include the number, and you're going to use brackets to close it in when you do include it, when you have greater than or equal or like less than or equal. Okay, now I just want to show an example here. You know, the notation will say all of x, here's brackets, all of x such that, here's the inequality, x is greater than 1. You know, in the old days, you graph your line, here's 0, you find 1, you're going out, here's 2, don't forget your arrows, here's negative 1, and which way do you go? X is greater than 1. So you find 1, and we used to would put an open circle because it does not have the equal sign with it, so we'd go like that, and greater than is always to the right, and then we would highlight like that and color it in. That's an arrow, believe it or not. Okay, so now when we do it, instead of putting an arrow, you're going to turn around, find the 1, think of it as the anchor point which way you're going, so make sure you use the parentheses. I always associate the parentheses with the open circle. That's how I remembered it until you get used to using it, and then you go ahead and go in that direction. Remember, the open end always points towards the greater side. Okay, now once you've done that, then you've got to do that interval notation. This is an example of it right here. I recommend that you do the graph first, then do the interval notation. And so look at the graph. What's the smallest value on this graph going from left and right? There's the 1. So the first number is always the smaller number. The next number with a comma is the separator. Tells you to go from the smallest to the largest, and so now you're going on forever and ever towards positive infinity. Okay, we chose parentheses because it did not have the equal sign, so just like from the graph, you pick the right hand parentheses, and whenever you have infinity, you always use parentheses. You can never actually achieve and touch infinity because it goes on forever and ever. Okay, so that's the idea here. I picked an example here. Half of it being open here. So what happens if you've got a situation where you've got parentheses, brackets, parentheses, all of x such that x is less than or equal to negative 1. Okay, now the old days, again, just real quick, here's 0, here's negative 1, here's negative 2, and you see the less than or equal. Make sure the variable is on the left hand side. I want to make sure I point that out to everybody. When you graph these, make sure that variable is on the left hand side. It's usually given that way, but every once in a while it's not, and I will help you with an example of that down at the bottom of this page. Okay, so let's go back to this. Let's graph this the old way real quick just to make sure everybody's with me. I find negative 1. I want all the values less than. In the old days we used to put a circle, a closed circle, to represent including the negative 1. We're going less than, so we go to the left. Okay, now how do we do it now for the book? We're going to find negative 1. We're going to go to the left. Your starting point is a bracket because you're going to include the negative 1 because of the equal sign, and you draw your line. Again, the interval notation, what's the smallest value? Look at the graph. You're starting from negative infinity, and this is a mistake in the class notes. Make sure you put that minus sign in there. Comma, what's the largest value we're going to? Negative 1. Do we include it? Yes, and you put the bracket. Okay, so we're kind of getting the hang of these things, so let's go ahead and pick up the pace just a tad here. What happens if you were given an interval such that x is now look how I'm reading this, x is greater than or equal to 1 and x is less than or equal to 4. Okay, now we've got equal signs on here, so I know I'm going to use brackets. So I find, here's my 0, I find 1, I give myself a left-hand bracket, I find 4, you're going to go in between it, so x is between it, and then you're going to highlight in with a line in between them. Okay, now the interval notation, what's the smallest value on your graph? 1. What's the largest value? 4. Do you include both of them? The answer is yes. Because of the equal signs, you put your brackets and you're done. Okay, so let's go ahead and look at objective number 1 here. How are we going to use these inequality equations? Biggest thing we got to remember is I tell my students in class, whenever you see the inequality sign, you've got to think of that as like the equal sign, and it separates, okay? And I like to maybe show a wall going down here. It separates left side from right side. All your algebra properties for solving the equation you're going to use, we're going to come up with we have to know one special rule, and we'll cover that when we get to it here. So how can I solve and isolate x? Negative 7 is on the same side, so I'm adding 7 to both sides. This adds up to 0. I like to have x less than negative 5. Okay, so that's all you have to do here if you want to graph this real quick. I find negative 5 on my graph. I'm doing x is less than, not equal, so I give it the parentheses. I'm going smaller, so I go that way to the left, and I'm all right. Okay, the interval notation again, you're going starting on your graph. I'm negative infinity. You're stopping, and the maximum value is negative 5, and you do not include it. Okay, now here's another example here. Number 2. We're going to solve for m. It's on both sides of the equations. I'm going to choose to move, M-O-V-E, the 2m over to the other side via the opposite sign. So I'm going to minus 2m on both sides. I have 14 less than or equal. I leave the signs alone. You always leave them alone until you hit the rule. Finally, 3m minus 2m is 1m. And now what I'm going to do here is you've isolated. Now, this says 14 is less than or equal to m as you read it from left to right. The key thing now is to read this from right to left. So this says m is what? Greater than or equal to 14. As you read it from right to left, when you read it that way, write it down. M greater than or equal to 14. Write that. Make sure the variable now is on the left-hand side. M greater than or equal to 14. Okay, once you've done that key step, transforming, if the variable happens to be on the right-hand side, rewrite it so it's on the left-hand side. Now, there's a couple ways to do that. I talked about reading it. Some of you might be comfortable with switching the sides and switching the signs. Whatever works for you, but I strongly recommend you get the variable on the left-hand side, because now this says graph all of them greater than or equal to 14. So you start your graph, here's 0, you find 14. Do we include 14? Yes. So we're going to put the left-hand bracket because we are going to go greater than, and we're on our way. And there's your set notation, interval notation. Include 14, comma, you're going to a positive infinity. And you do not have to put the positive with the sign within positive infinity. Okay, so that's those two examples here. We're going to start objective 2 here, but we're basically going to do this on the next video. Solve linear equations when you multiply or divide. Big thing right here, if you multiply or divide by a negative number, change the inequality sign when you do it. Okay, so we're going to show some examples of that, and that's the only thing you really need to learn as far as solving these inequalities is if you multiply or divide by a negative sign, you must change the inequality. Okay, so that's all we got here for now, Mr. McHugh. Signing off, and I'll see you for page 2. Bye.